Kejap. Saya silap sikit ni, saya silap. Okay, selama ni kita belajar how to set up equation of line in 2D. Kan, in 2D. So where we need slope, right? Slope is represented by M, okay? And also at least 1 point on the lines, okay? It allow us to set up the equation of this straight line, y equal to mx plus c, right? Okay, by using, you can use this formula or this formula. This is about for 2 dimension. Now we move to 3 dimension. 3 dimension, yeah? Because of vectors and memang we deal with the 3 dimension, most of the problems kita. Okay, so now, in order to set up the equation of line, we must have the 2 information as well. Okay, so the first one is direction of the line. This is represented by the M here. Okay, so this one is described by a vector parallel to the line. Memang bising sikit ni on. Memang bising. Saya memang aku sangat bising sangat. Tapi fokus. Fokus. Okay, direction. Described by a vector parallel to the line. I would like to highlight sini memang dia akan bagi kita the form of the slope itu given in vector, ya. Most of the time lah, tapi sometimes juga dalam point juga. Tapi kita akan tengok dia punya idea. Second, we must have at least 1 point. Itu memang syarat to set up equation of line. Ya, kita same. The idea is similar to set up the equation of line in 2 dimension. Okay. Okay, jom kita baca this page here. This is actually this is a summary for what I explained here. Okay, the line. Okay, we must need a point and the direction, the slope, right? Okay, in 3 dimension, we must have the direction of L. Okay, direction of L. And described by a vector. Normally it's described by vector. So, and the vector here must be parallel to the line that we are looking for. Yeah, the idea, if you see from the notes, it is different with the plane equation. Plane equation kita akan belajar on how to set up the equation of plane. Then you can. Now we are going to set up equation of line. The idea of this vector must be parallel to the line that we are looking for. Kan? Kita memang sebab sekarang ni isu kita memang nak set up the equation of line tu. So vektor yang kita nak mestilah parallel to the line. Okay, parallel to the line. Okay, if you can see from the picture, dia tak picture okay, here. Okay, this figure 1, yeah. This is not so clear. This figure 1 dia kata apa? Let P, okay, P is arbitrary point, maksudnya apa-apa point je lah. Okay, P ni general point on this line, okay. On line L, okay. And let R0 and R be, these 2 vectors, be the position vectors of P0 and P. Okay. Yeah. So here, okay, as recall back what we discussed last time. Okay, this is the vector R0. This is vector R0 and R. Okay. Bila kita start position vectors P0, P. Okay. Be the position vector P0 and P. So we can write this vector R0 and R as this, right? OP0 and OP, right? Is it? Kan kita dah belajarkan sebelum kan? Kalau ada point kat sini, so this vector ini, kita nak write the vector, we can write OP0. Then from this O to this P0. Okay. Okay. And also this R, also this vector can be represented by OP. Kan? So to get this value, to get this vector, we know that this terminal minus this initial. Can now this is position vector, so it means that this is x0 minus 0. Kan? Y0 minus 0 and Z0 minus 0. Kan? So that's why what can we what we learn about position vector is this coordinate is also represent the vector. Kan? Ini adalah juga represent R0 ni represent juga X0, Y0, Z0 ni ada vector because it starts at position vector. Kita startkan dia. Okay, this one is also so R0 can be written as X0, Y0, Z0 kan, and actually is X0 minus 0, Y0 minus 0 and Z0 minus 0 ni is actually yang this one is explain. Same, this idea is the same for this R also X minus this O lah X, Y, Z. Kita baca line by line cerita dia. If A is the vector with representation P0, okay, dia kata A ini as in figure 1, then the triangle law for vector addition gives R equals to R0 plus A. What we are discussing is about on how to set up the equation of line. And bear in mind that we need these two information to set up the equation of lines. Sekarang ni tengah proses nak set up equation of line. What is the equation should be used? Okay, dia tengah nak cerita lah ni. So dia kata, kan, R ini, this R equals to this. Hold on, saya dah record ke you on? Saya tak record lagi kan? Saya record ke ni? Saya record
Record sudah.
Sudah. Okay, thank you. Okay. So, idea ni dia kata based on the triangle law, kita tahu this R equals to this R0. Look at the arrow, right? R0 plus A. Okay, R0 plus A. Okay. So, to get R, so that's why we have this relation. Yeah, we have this relation. And this relation also, it tells us that dia kata, since A and B adalah parallel vector, then this A and V are parallel vector. There is a scalar T such that A equals to TV. Thus, sebab kalau dia parallel kan selama ni kita belajar kan, saya kata kalau parallel we can check the scalar multiple lah. So they are parallel, so we can write such this apa ni kan. So this can be written as this R equals to R0 plus TV. So it means that R ini if you see, kita ingat dua perkara ni mesti ada one point on that line. So R0, if you see, is actually the point here lies on this line. Dan memang kita nak satu point. Okay, satu point, at least one point on the line. One point there is R0 here. It's R0, which is this R0 lies on this line. Okay. Second, we need the parallel vector. If you can see here, parallel vector here is given here. Sometimes, yes, it gives you a parallel vector straightforward. Dia bagi macam, so the parallel vector is this. You can imagine like this lah. This parallel vector, okay, is also parallel to this line. Kita perlukan parallel vector, one parallel vector. But sometimes it doesn't give such this. Kita kena faham, we must have an ilmu that parallel vector is also can be obtained through this line. Line ini is parallel to this vector. Sometimes kan dia tak bagi this vector ni, dia tak bagi the value of this vector. Dia bagi, nampak kat sini, dia bagi 2 points. 2 points. From these 2 points that lie on this line, can these 2 points, we can find the parallel vector? Boleh tak kita cari? Okay, tak apa. Kalau macam kita we are still, kita still lagi digest kan? Kita still digest. Cuma I would like to highlight kat sini, the question sometimes dia tidak bagi straightforward parallel vector dia apa. In this one lah, parallel vector dia apa. Not such that. Sometimes dia bagi 2 coordinates on this line. So we still can find the parallel vector because V and A are scalar multiple. Yeah. So tak apa, kita akan follow through the examples. Okay. Cuma nak beritahu je. Parallel vector here diberi, and also this parallel vector is parallel to this line. Parallel to this line. Yeah. Okay. Itu je dulu, tak apalah from this picture. Okay. Okay. So here, so we have this formula. Yeah, we have this formula. So if you are asked to find the equation of line, line. Normally we have 3 forms. We have 3 forms of equations. First one is the vector equations. Second is parametric equations. Third, symmetric equations. So these 3 equations can be presented as an equation of line. Yeah. Okay. So kita start with vector equation first. Sebelum tu nak cerita lagi, R0 is the coordinate, yeah, passes through the line. Dia mesti R0 ni sejenis koordinat. Tapi R0 ni vector, so dia position vector kan, so this coordinate can be written as a vector. Okay, and also V pula is the vector that is parallel to the line. Yeah, okay, tu dua tu mesti ada. Okay, to set up equation of line. Okay, okay, this is vector equations. Okay, we start vector equations. Each value of the parameter T gives the position vector R. Okay, ini dia cerita lain buat ni. Okay, ini dia cerita baru dia cerita satu form ya. One form of the vector of the line equations in vector form. Ya, dalam bentuk vector equation lah. Ini symmetric, ini parametric. Nanti saya akan relatekan these 3 equations. Ini saya follow this slide ya. Okay, tak apa ni. Lagi saya follow lah di slide supaya tak terskip. Okay, ni dia cerita another point. Dia kata each value of the parameter T gives the position vector. Remember during in chapter 1 kan, bila kita vary the T itu actually represent the parametric equation kan, X in terms of T kan, Y in terms of T, so it represent the coordinates. Okay, the idea is the same. Parameter T give the position vector R of the point on L. On L. Yeah, so as T varies, the line is traced out by the tip of the vector R. Okay, so pendek kata, okay, line ini is actually the collection of T ni, right? Okay, untuk R0 memang dia always starts at T equal to 0. R0 dia punya P0 kan, you nampak? Dia punya macam permulaan dia tu kan, the initial dia tu. Okay, R0 ke P0. Dia ni kalau kita set up equation pun nanti you nampak dia mati equal to 0. Apa nanti dulu kita tengah cerita lagi ni. Okay, and then dia kata apa? Positive value of T correspond to the point on L that lie on one side of P0. Kan? Kalau di sini, kalau from this figure 2, kata T positive, this is another side. Okay? And then negative pula is this another side. Tiba is another side from this P0 lah kan dia punya ni. Okay, from this point P0 dia. Okay, so because sometimes we need 2 points sometimes. We need 2 points. Kan? So, how do we know? By substituting this T ini with any value, so we can get a few points. Kena ada ilmu lah, ilmu ni Maksudnya, tak apa nak beritahu je dulu ya. So bila kita dapat nanti vector equations ke or parametric, symmetric, when we substitute the T, right, nanti we can get another point from that lies on this line. Yeah, okay. Ini dia cakap apa lagi ni? If the vector V that gives the direction of the line L is written in component form, okay, V, okay. Dia kata sinilah. If V here is parallel vector, dia kata component form. And we know that this is the coordinate as well, right? Okay, this A, B, C. These are coordinates. And this also can be written as a vector like this. Because this V pun start at position vector kan. Start at 0, 0. Then we have, okay, this. Dia senang guna. Misalnya dengan X, Y, Z, X not, Y not, Z not. So ni ada A, B, C. So kita boleh, we can write the equation like this. Okay. This is the, kan kita punya tadi lah, R equals to R0 plus TV. TV. Okay, this is the coordinate that lies on the line, and this is the position, this is the parallel vector. Yeah, parallel vector. Okay. Okay, so now we can, when we expand it, expand this equation, it become like this. Okay, R tadi, this R, and at this point is X, Y, Z. So X, Y, Z actually lah, sebenarnya kita X minus 0, Y minus 0, Z minus 0. Okay, and this is R. R is, what is that? R naught is X naught minus 0, based on this equation. Okay, R naught, okay, R naught is X naught minus 0, Y naught minus 0, Z naught minus 0, right? Plus T. Okay, T I just T, V is vector A, B, and C. Okay, this one is actually A minus 0, B minus 0, and C minus 0 as well. Tapi we just need to write such, this pun dah okay. Dah understood dah. Yang minus 0 tu. Pasti this one is apa tadi? A minus 0, B minus 0, and Z, BC minus 0. Okay, why I minus by 0? Because this vector, let's say, or this one, right? O P naught. So O P naught, so P naught minus 0. And this terminal minus initial. This terminal minus initial. That's what I'm trying to say. But now basically you can just write such this. Okay. Two vectors are equal if only if corresponding components are equal. Yes, kita ada we have two vectors, correct components are equal. If you notice from these equations of line, there are a multiple of representatives sebenarnya. Banyak kita boleh representkan. You can write this vector equation in many forms. Here we will look at after throughout this slides. Okay. Jadi this one is the equation of vector. X, Y, Z equals to T naught plus TA, Y naught plus TB, Z naught plus TC. Yeah, it comes from this equation. R equals to R naught plus TV. So you have to start writing. Kalau soalan tanya, you have to start from R equal to R naught plus TV. Can tulis itu, that formula. What is R naught is the equation passes through on the line. V is the parallel vector. Yeah, we'll imagine like this. Okay, and this parallel vector must be parallel vector to the line. to set up. Kita nak set up ni equation line ni lah. Okay. So this is another form of equation of line, which is parametric equation. Okay, if you notice, the parametric equation is actually comes from the vector equation. Kan? What we do is we just break kan? X, okay? We take out this component, x0 plus at. EA or at is the same. Okay, y, okay? And then take out y0 plus TB. Right, Z, and then Z0 plus CT. Okay, just take out the equation itu, make it separate X, Y, and Z. Just like this, the parametric equation. Okay, the parametric equation of the line through this point. Okay, we know that this is the coordinate, the coordinate X, Y, Z, yeah. So y0 is the coordinate passing through. Yes, the coordinate. This is the coordinate apa? On the line. Line yang kita cari tu. Okay. And A, B, C. Apa? A, B, C is the parallel. Is the parallel vector. Okay. Dia punya position macam tu. The coefficient of this T is the parallel vector. Not the coordinate. Yeah. Okay. Because we have to know how to read from this equation. Kita kena tahu, oh, parallel vector dia, oh, the coefficient of T here. We must know. Okay, next. Okay, let's go to the example. Okay, example 1. Okay. Okay, symmetric belum lagi masuk slide lagi ke tak apa. It's okay, symmetric nanti kita akan study. Actually, it comes from this idea. It comes from this idea. We can do the arrangement to get the symmetric equation. Okay, let's look at this slide because I just follow through this slide. Okay, example 1. Look at this. Oh no. Okay, this is example 1, right? Okay. Find a vector equation. Okay, this question asking the two form of equations of line. Satu tu bentuk vector, second bentuk parametric. For the line that passes through, okay, get this coordinate and this parallel vector. Okay, nampak tak? Okay, these questions are very straightforward questions because dia bagi kita what we need to set up equation of line is one is the coordinate and another one is the parallel vector. These two information kita mesti ada to set up equation of line. So we are given these two information. Satu tu point passes through the line yang kita cari. Second is the parallel vector. 1, 4, 82. So we just straightforward substitute into the formula. So in the formula we start from vector equation. We know that R equals to R0 plus T V. Okay, this one. So we just write R is X, Y, Z and this coordinate X, Y, X not Y not Z not actually, right? So now we are given 0.513 and this point as what we know, this also can be written as the vector, okay? Because it starts at position vector. So 513, now we write in the vector form plus T, okay, and then this one bersama V kita, this is parallel vector, it's given in a parallel vector form. So we just substitute into this. So terus dia buat the vector equation is this. Okay, kita combine kan. 5 plus T, comma, 1 T, comma, 3 plus, negative 2T. So this is the equation of vector. Okay tak you all?
Okay.
Okay, cantik. Okay, then, okay, since we are asked the second form, another form of the line equation, yeah. So parametric equation. So based on this vector, we can write X, Y, and Z. So X, Y, and Z. And then 5. This one is the coordinate that passes through. So 5, 1, and T. Yang parameter kita, we start from this vector, and from this vector we can write something like this, kan? X, Y, Z. Okay, so the coordinate passes through 5, 1, 3, plus, 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 and then T, T, T. Macam tu lah, kan? Ini X, Y, Z, parametric. So the passing through is 1, 5, 3, plus, 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 and then the vector parallel. So it should be T, right? T, 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 and then here should be the coefficient is 1, 4, and negative 2. We can write. If the question asking parametric equation, we can write such this. Boleh je. Kalau tak buat pada awal pun tak apa. You can write such this. Parametric senang kita boleh buat, kan? Terus faham je. This is the point passes through the line, and this is the vector parallel to the line. Tapi kalau vector kita kena vector equation. Kalau question tanya vector equation, you kena buat ni lah step ni. Kalau parametric ni, sebaiknya buatlah step ni, and then you dapat tulis dalam macam ni. Atau you nak skip, you buat macam ni pun, it's okay. Boleh je. Okay, itu satu. Okay, dah. For the line that passes through. Okay, dah, okay. Okay, done. Okay. Since kita belajar lagi simetri, kejap ya. Ini just yang tadi tu ya, refer textbook. Ini just sebenarnya actually dia kata to write R equal to R0 plus TV, it should be like this lah, 0, 0, 0 tadi. Okay, number 3 kita tak study lagi. Saya follow this slide. Dia kata kat sini, parametric equations are, okay, this one, right, 5 plus X equal to 5 plus T, Y equal to 1 plus 40, Z equal to 3 minus 2T. As what I mentioned just now, there are many representative. Yeah, when we talk about equation of line, dia memang banyak representative. Sebab, kita tengok satu contoh. Dia kata, kalau kita, this one ni, yang ini you all buat ni tadi ni, this one is when T equal to 0. So when T equals to 0. Sebab dia start tadi kan dekat R0 kita tadi is, R0 kita tadi is what? 5, 1, and 3 dia katakan. Dia start dekat point X0, Y0, Z0. Okay. And this point is memang T0. Bila start to 0 kan? 0, 0. Dia memang go to X, Y, Z. Okay. So 5, 1, 3, right? Okay. This is what bila T0. But now, we can write another equation of line by choosing different T. For example, bila T equals to 1. When T equals to 1, okay, our X, Y, Z will become 6, 5, 1. Kan? 6, 5, 1 ni sebenarnya dia lie on this line tau. 6, 5, 1 kat mana? Somewhere here lah. Somewhere here lah ya. Okay. So this is when T equals to 1. 0. So we have another point. So we can still write the equation of, for example, this equation of parametric. So X, Y, and Z. Okay. So the coordinate that passes through this line, we have another set, 6, 5, and 1. Okay. But here the punya T ni in this case B here, dia maintain lah. T dia kata 1, 5, negative 2, but tak mention apa-apa kan. Can you see? We have another set of equation of line. Okay. Same goes to if we decide T equals to negative 1. We have T equals to negative 1 is somewhere here. Dia mesti dekat T ni must be lying on this, must lie on this line. Yeah? Dia mesti. Kan jadi coordinate. So this one ada negative, ada 4, negative 3, 5. This is another coordinate. So we can write another set of parametric equation. Parametric equation. Sebenarnya bukan parametric je kan. Dia boleh, kalau kita turn back to vector, kita akan tukar sini lah. Tukar sini. Ya, tukar sini. Okay. So, sini 4, negative 3, 5, sini plus, 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 sini T, 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 sini, in this case, dia tak discuss tentang polar vector, so the polar vector is the same for negative 2. But what can we see is there are 3 sets of parametric equation. And as well, the 3 set of vector equations lah. Maksud saya, if you can write this parametric such as this, it means that kita alter sini. Kan kita alter here. This is 6, 5, 1, right? To allow us to get this equation. So kita tukarkan dengan 4, negative 3, 5 here. Yeah, okay. To get another set of vector equation. Nampak tak you all? Equation offline dia memang boleh macam-macam. Tapi my advice is biasanya, saya advise you all buat bila T0 je lah. Bila T0 je. So as pemeriksa, kita memang kami akan kena carilah apa yang student biasa akan buat. Kan sebab ada banyak set skema lah macam tu kan. So dia memang boleh equation offline. Compared to equation of planes, yes, they are consistent. They are consistent. It's just a skala multiple je. Untuk bulan lain juga tapi just skala multiple. Maksud saya kalau nantilah equation of plane tu kan. Okay, jom kita tengok ni. Hari ni saya akan habiskan awal tengok saya punya objective is I would like to ask you to digest first the equation of lines. So my planning for today is equation of lines and then continue with some discussion on 12.5 exercise. Maybe next time, next day lah kita baru saya akan bagi untuk planes. Untuk plane lama sikit lah. Tapi saya tak nak mix lah. Saya nak you all digest dulu equation of line. Sorry, maybe sekejap. You all, kita ada pause time kejap. Saya kena ambil darah sekejap. Kena ambil darah hari ni. Saya sekejap dalam kurang 5 minit. Saya nak kena cucuk sekejap ambil darah sekejap. You all boleh digestkan. Pukul 11.10 tadi something. You all boleh digest what I'm trying to say here. You digestkan your either symmetric ni. Okay. Symmetric. Yeah, this one and this one. Okay, sekejap saya tutup sekejap. Sekejap bagi saya kurang 5 minit. Ya, bila saya tutup kamera, you all tetap nampak tak slide saya? Okay, saya tutup kejap Sekejap. Okay. Okay, saya continue. Yeah. Okay, so far from this idea just now, do you understand? Faham ke? Dengar suara saya ni? Dengarkan suara saya.
Dengar.
Okay, so far nak cerita je ni, the equations of line, okay, there are multiple of representation. Representation of equations. Okay, not unique, dia kata. Okay, this is the, if we substitute t equals to 1, t equals to -1 kan into this equation. Okay, other than that, dia kata ni bentuk lain pula, dia kata. Instead of 513, we choose the point 655. Ini yang tadi lah okay. Yang tadi tu 6 plus t, so it become this one. It's become this one. 5 plus 40 is equal to 1 plus -2. Okay, it become like this. Okay, dia kata atau we can write the equations where we maintain the point, but we vary the parallel vector pula. Dia vary kan, bukanlah vary macam mana. Kita buat skala multiple lah, the parallel vector ni, kita faham, kita belajar. Then this parallel vector boleh this vector we have V, and this is 2V, right? For example. So they are still parallel. So tadi is 1 for -2. So we can change, we can multiply by 2. So become 2, 8 and -2. So we can write the parametric equation. Yeah. Okay, maintain 513 as just now is a point. So, but dia punya parallel vector tu become double dah sekarang. Boleh juga. Kan? Boleh juga. Okay, saya cakap tu lah. Ni tak berapa ni direction numbers of L ni A, B, C ni. Kita berapa je lah Okay. Equation of line. Okay, this is the symmetric. Okay, rasanya you all dah faham dah idea on how to write the vector equation where we need coordinate passing through the line and juga vector parallel to the line. Mesti dua information kan, R equal to R0 plus TV. Okay, and this one can be written as parametric equation. X, Y, Z. Okay, this is coordinate passing through plus T, and then the coefficient when the parallel vector dia. Okay. And okay, the third one is symmetric equation. Symmetric equation, okay, apa yang you all faham tadi yang saya minta you all baca? Saya minta you all baca tadi. Okay, Mira boleh ke cerita sikit how to write the symmetric equation? What do you understand from this answer?
All the point are equal.
Macam
Dia sama-sama je. Point X, Y, Z tu dia nilai dia sama, gitu kah?
Betul. Okay, so symmetric equation, if you notice, okay, parametric it should be in vertical line, saya boleh katakan in vertical form. Okay, and also actually boleh je nak buat dalam bentuk macam ni, boleh je. Okay, but I would like to tell you symmetric, but kata Nabil tu sama saja, yes. Cuma nampak tak? Okay, if you notice kat sini, in the symmetric there is no variable of t. There is no variable of t. Tak ada. Sebab soalan boleh tanya, minta tulis equation line dalam symmetric, so kenalah tuliskan. But normally in order to write the symmetric, biasanya you akan start dengan parametric ke, senang saya suka start dengan semuanya pada parametric lah. Kalau question tanya vector equation, baru saya akan buat R equal to R0 plus TV ni. Kalau parametric saya terus je buat benda ni. Okay. Kalau you tengok symmetric, it is easy to write from this parametric. Okay, where you let T ni be the subject. You let T be the subject. You do the arrangement. T equal. Equal apa? X minus 5. T equal apa? Y minus 1 divided by 4. Kan? And this one. Okay. So once we get T be the subject, so the rest or the right hand side kita ni, we take out, we put it here. Kan? Kita letak kat sini. And separation dia orang ni adalah equal. Nampak tak? X minus 5 divided by 1. Sebab ni tak ada ni kan. Dia kena bentuk dia something like this. The form would be like this. X minus x naught divided by A. Okay, y minus y naught divided by B. And this one. Okay, if you notice, x naught, y naught and z naught ni, what is this? What is this coordinate? Apa dia? Coordinate apa? Passes
not.
through
Oh,
the point,
passes.
the line kan?
Yes.
Okay. And A, B, C, what is that? The parallel vector, right? Kan?
Yes.
To the line. Yeah. So pattern dia gitulah. So X, Y, Z must be, okay, it's a must. Okay. And then X naught, Y naught, Z naught. Okay, this one ni 5, 1 and 3 kan? From this, 5, 1 and 3. 5, 1 and 3. Negative is a must, okay? And then divided by the vector. Parallel vector 1, 4, negative 2. So 1, 4, negative 2. Macam tu. Yeah? So how do we get this? You buat yang ni. Can let T be the subject. Okay. Okay. Sometimes yang question bagi macam ini, question bagi, but you have to know what is the parallel vector, what is the coordinates kan. Normally my advice is you write back the equation in the parametric equation. Kadang-kadang macam ni, kadang-kadang kita risau soalan tu, kadang buat macam ni lah, kadang dia letak negatif kat bawah lah. So susah sikit lah untuk kita nak, takut tersilap untuk kita identify what is the parallel vector and what is the coordinate passing through the line. So saya lebih suka kalau dapat soalan macam ni, kita rewrite this equation in parametric equation. So we can see by cara macam mana? Buat T equal to this, T equals to this, T equals to this. So do the arrangement, buat macam parametric. So you dah dapat identify betul dah what is the coordinate passing through, what is the parallel vector. So sometimes we need to find these two information. Saya faham kot ni. Okay, ni saya nak ke sini. Okay, before we go to this, saya want to extend sikit question ni tadi. Question number 1 kot. Question number 1. Ni lah. Ini kalau yang find saja ada 7 other points on the lines kan. Tadi tu kita dah buat T equals to 0, the 5, 1, 3. Yeah. We substitute into this. Boleh je parametrik ke dalam vector equation. So yang saya buat ni saya substitute in parametric equation. Yeah. Okay, so T equals to 1 tadi 6, 5, 5. T equals to negative 1, this one. If you look at, if you continue substituting, you will see the coordinates is memang lie on this. Bila you buat collection of this point ni, you akan dapat the line. Okay. And this one is at T equals to 0. Dia punya initial kita cerita. So maksudnya, saya nak cerita je lah. Ya, kita akan dapat point ini allow us to set up the equation of line. Line kita ni memang tak ada line of parabola ke apa ke, tak ada. Dia memang equation of line ni memang equation of straight line. Ya. Okay. So, jom kita teruskan. Example 2. Example 2 saya belum lagi ni. Okay, example 2. Look at this. Example 1, dia bagi straightforward. Dia bagi one point and one parallel vector. Kan? So these two information memang kita perlukan. Okay, example 2. How about if you are given 2 points but we are not given the parallel vector. We are not given the parallel vector. Itu tidak diberikan. Tapi we are given 2 points. 2 point ini lies on the line. Yang kita nak cari tu. So, okay, now we are asked to find the parametric symmetry. Okay, so we are given point A, point B. So, let's say this line yang kita nak cari. But, on this line, there are 2 points given. Point A and point B here. Macam tu. So, we want to find the parametric. So, to be easy, yes, first, we need 1 point. So, point, yes, you can use A or B. Okay? But the second issue is the parallel vector. What is a parallel vector here? How do we find it? So the parallel vector is what I mentioned just now in V and this A tadi. Ingat tak tadi yang A? A itu, okay, this vector they are parallel right dengan V ni. So this vector A ini can be obtained through apa kita buat yang ni lah kan? AB or boleh je BA, boleh je. Or boleh je nak buat times 2 ke kan? AB, boleh je. Parallel vector kan? Pasal kan dia are parallel. Faham tak maksud saya ni? Okay, point kita boleh layan. Point tu boleh pakai point A, B, ni kan? Point A or point B. 3 negatif apa ni? Plus, 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 T, 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 T. Okay. And then parallel vector now is obtained through finding AB. Kan AB. So kita buat ni. So AB kita akan dapat apa? Terminal minus initial. So we get 1, negative 5, 4. So just substitute into this. Or BA. Boleh je. Rasakan dia parallel. Ceritanya dia kena parallel. Parallel ni pula. Kita memang boleh dapat tadi. Kita dah ceritakan dekat gambar tadi kan. Yang figure 1 tu. Ya. Yeah? Figure 1 here. No, figure 1. Figure 1 here. Apa yang kita buat tadi tu is actually we are calculating this A lah. And this A, they are parallel. So this A can be obtained through, boleh juga ni kan. Kita ada 2 points. Kita A boleh dapat P, P0. So kita buatlah. Apa? Kan terminal minus initial. P0 minus P akan koordinat ni minus this, koordinat minus this, koordinat minus this. We get this vector. Kan? Boleh je. P not P boleh je. Ataupun half daripada P not P. P not P kan. Ataupun tak tu yang kita ada example tadi. Dapat tahu ada boleh. Tapi yang senangnya. Okay, just take out A, B, C. So point A, point B, plus, plus, plus. Okay, and the parallel vector can be obtained through the deducting between these two points. Yeah. Faham ke you all?
Faham.
Okay, jom kita teruskan. Okay, this question, example 3 ni memang very famous questions. Very famous question you all. Show that the lines L1 and L2, your line ni memang you all memang kena faham betul-betul tau. Sebab dia related dengan plane tu. Plane tu lagi dah banyak cerita ni all. Kalau you tengokkan slide, saya banyak juga slide plane. Tapi saya plan tak nak. Kalau you all nak kita discuss lah, bolehlah. Kalau nak teruslah. Ataupun you ambil pause time. Kita akan tengoklah you orang kata apa? You get the feeling first, end of this discussion. But dah nak habis dah ni. Nak habis dah ni. line, okay tak apa. Ikut you all, ikut je lah. Kalau you all nak plain equation straight, terus discuss pun boleh, ataupun you try to get kata tune dulu, dapat tune dulu buat example exercise 5.5. Sekejap kita habiskan sekejap. Example 3. Okay, example 3 ni show that the lines L1 and L2 with parametric equations are skew lines. Okay. How can we imagine the skew lines itu? The skew lines itu, as you can see, there are three forms, there are three patterns of line. The first one, we can say that these two lines, when these two lines are parallel, nampak kan parallel tu, so parallel lah line ni. Then this line and this line. Then they are parallel. Okay, parallel line in the parallel. Okay. Okay, look at this. How do we determine? Okay. Last week we discussed about parallel. Juga kan? But last week it's about the vector. Can determine the vector one, this vector and this vector parallel. Kan kita nak bukan parallel tu based on the vector kan? Okay. Ingat ke tidak tu ya? Kan kita buat skala multiple, ingat tak? Kita buat skala multiple kan, nak determine vector lah. Okay, but now dia cerita tentang L. This line and this line, they are parallel. But the way to check is, memang kita guna the vector again. V1 parallel to vector 2. Dia memang, if vector 1, maksudnya this is a parallel vector lah kan. Okay, because we know that this line equation, we will be given something like this kind equation. Okay, so saya call it. Never mind. Ada kelas. Okay. Okay, on. Okay, as what we know, equation of line. Okay, the first term is coordinates plus, and t is the apa tadi? Parallel vector. Okay, parallel vector. Okay, this one yang kita nak. This is this part. This is the V1. Kan, for this line L1 and L2. This is a V2. Okay, so we take out this V1 and V2. What is the parallel vector for this each line? And then we check. They are scalar multiple or by buat macam ni je lah. Yang ada 3 method tu kan. Saya kata scalar multiple. Bentar lagi saya tak ingat lah dah. Kan yang theta tu lah. Kan dapat pi or zero, right? Ingat tak benda-benda tu? There are 3 methods kan. Ataupun cross kan, kalau jadikan zero kan, dapat zero. Ingat tak tu? Okay. Okay, itu kalau parallel. Saya ada letak ni, ada a few ada solution yang saya attachkan bawah ni, example. Okay, second question akan tanya, itu kalau parallel ya, so dia tidak akan bersentuh. Okay, ataupun situ juga lah kan. Itu boleh juga kan parallel. Okay, intersect macam mana? Parallel maksudnya sentuh boleh lah kan kalau logiknya you all. Okay, intersect macam ni you all. Intersect dia akan, okay, intersect lah kan. Okay, intersect. Okay, intersect. Dia memang touch. Dia akan ada satu intersection point. Okay, L1 and L2. Okay. Intersect kita buat macam mana you all? Okay, intersect ni nanti kita discuss ya. Ni kita discuss idea dia. Okay, previously kita discuss about parallel 90 degree kan. Okay. Ini pun sama juga. L1 intersect to L2 kan. Nak beritahu je, tak apa, kita akan tengok how do we check for the intersection point for L1 and L2, yeah. Okay. And then lastly is L1 skew to L2. L1 skew, ini kata ni skew. Then show that L1 and L2 are skew. Skew tu maksudnya adalah dianya intersect. Dia tadi datang daripada intersect ni sebenarnya. Tapi dia tak. It doesn't touch. It doesn't touch each line. Okay, dia nampak macam from the top, we see that it is intersect. But when we go here, and then dia shift. Dia tidak bersentuh. Itulah namanya skew. Skew ni idea dia memang macam dia bukan parallel, dia bukan parallel. Parallel dia boleh macam ni, dia boleh macam juga sebenarnya you all. Ya, tapi intersect dia skew dia intersect, tapi it never touch each other. Dia tidak okay, nampak tak ni? Oh.
Nampak.
Okay. Sebab saya tak nampak muka saya kat sini. Tak tahu kamera saya kat mana tu. Okay. Okay, so maksudnya bila skew ni, they are not parallel and not intersect. So it means that kita kena provekan dulu. Mereka ni not parallel and not intersect. Okay, so jom kita tengok. Cara nak tunjukkan mereka ni not parallel dulu. Okay, jom. Bismillah. Dan ada satu example yang saya detail out dia punya ni. Cara you all nak buat. Okay. Okay, this different questions. This one is saya tulis solution untuk yang this example. So B je untuk your punya homework. Kan? Okay. Example, look at this example. Example 3. Show that the line L1 and L2 with a parametric equation are skew. Okay. So first we have to check L1 is parallel to L2. To find this the V1. What is the V1 here? The first step saya pakai step. The V1 here, what is V1? So L1 say indicate this one is the V1 is indicate. The V1 is a parallel vector there. What is this here? 1, 3 and -1, right? Okay. And V2, what is V2? Okay, the parallel vector is 2, 1 and 4. Right, okay, we got this one first. Okay, now we would like to check parallel. Kita nak check, okay. V1 and V2 parallel. Okay. If V1, V2 parallel, then we can say that L1 and L2 are parallel. Dia macam tu. Nak check line tu parallel ke tidak, kita kena check dia punya V tu. Dia punya vector. Kan? Okay, so check dulu V. So kita buat skala multiple. Kita buat V1, adakah, boleh je V1 equals to K, saya dah biasa yang macam ni, so saya buat je V2, okay, or boleh lah bukan V2 equals to K V1, boleh je skala multiple tu. Okay, try buat what V1 is 1, 3, -1 equals to K oh here. So kita equate 1 equals to K. What is K? 3 equals to 1K. K is 1/3. 3 over 1. 3 over 1. Okay, dah nampak tak sama dah. Okay, you tak nak completekan pun tak apalah. Kan sebab dia memang nampak tak sama. Okay, 4K. Itu berapa ni? -1 over 4. Okay. So, kita kata since, kita kata apa? Okay, since V1 cannot be expressed as a scalar multiple of V2 or vice versa. Vice versa ni, yang boleh Okay, then V1 and V2 are not parallel. And due to that, bila V1, V2 tidak parallel, baru kita boleh conclude that L1 and L2 are not parallel. Okay? Faham ke, Iwan? Okay. Okay,
Faham.
same take you all, thank you. Same goes to this one, to check the parallel. Sama juga, okay, we write down this one kan, dia punya, the V here, okay, this down the V here, these two, take out, and then check, skala multiple, and then they are not the same, then we say the same thing, yeah. Okay, V1, V2 are not parallel.
Doktor, tak dengar suara. Tak dengar, doktor.
Sekarang dengan selesai dah ke, you all? Dengan selesai ke, you all?
Ada bunyi dah tapi tak kuat macam tadi ya.
Dengar dah? Kuat? Dapat dengar ke? Dengar tak?
Boleh tapi slow sikit lah.
Okey. Saya kamera ni. Saya ambil kedai. So, sekarang suara tak dapat dengar langsung tapi dengar sikit lah. Dengar lah juga.
Dengar jugalah doktor.
Kita sikit tadi. Saya tutup. Nak internet dia yang undang tengah-tengah. Tapi saya harap masih dapat. Saya boleh fokus lah ya. Harapnya boleh fokus ya. Sikit lagi. Okey. Okey. Yes, boleh dengar tak suara saya? Okey. Sekarang kita nak check line L1 and L2 intersect. Then check, how do we check line L1, L2 intersect? Okay. Yo, are you with me?
Yes.
Pertama is kita equate the equation. First. Equate the equation means we groupkan x by x. This x 1 minus 2t equals to 2 minus s. Kita equate t and s. Equatekan dia. Dan accordingly, maksudnya x, y and z group accordingly. So x, okay, 1 minus 2t equals to 2 minus s. Okay, 3 plus 2t equals to 4 minus 2s and so on. Okay, we make it 3 equations. Okay, jadikan dia 3 equations. Okay, if you notice kat sini, we have 3 equations, so I do the arrangement. Okay, let the unknowns all in one side and the rest is the values. Okay, so ada 3 equations. And when you notice that, kita boleh solvekan 2 equations. Okay, kita boleh solvekan 2 unknowns with 2 equations. Kan, betul tak? Ya, yeah. Kita boleh selesaikan, kita boleh cari 2 unknowns when we have 2 equations. Dah enough dah. Okay, so kita akan carilah. Kita akan solve any 2 je equations untuk mendapatkan S and T. Ya, macam for this example, I solve equation 1 and equation 2. Ya, saya solve. Dia tengoklah mana yang kita nak allow kita untuk dapatkan S and T values. Ya, mana-manalah. Ya. Okay, so kita solvekan 1 and 2. Kita akan solvekan 2 sahaja equation. So ada 2 unknown je. Okay, so solvekan simultaneously as equal to -1 for this example, example 2 nya. Okay, and then once we get s equal to -1, kita akan substitute s equal to -1 into any one lah kan, any one equation, and from these 2 equation kan. Okay. Substitute, masukkan t, kita akan dapat t. Kan, maksud faham kan? All solvekan any 2 equations because we have only 2 unknowns. Kita dapat, and then s equal to -1, substitute into 1 or 2. Dapat t. So now we get S and T. Okay. Once we get S and T, we will substitute these two into the other equation that do not related with obtaining S and T itu tadi. Kan, into 3, equation 3 lah dalam case ni. But we never use this equation 3 kan, to get S and T. So, bila kita equate, sokan dalam ni lah. Substitute into this. Okay. So, we find out dia tidak sama. Okay. So we can say that L1 and L2 do not intersect. Actually, what happened here is, bila kita solvekan equation 1 and N2, and we get S equal to -1, T equal to -1, actually, what do you understand? What we understand is, these two values give the intersection point. Maksudnya, X dengan Y ni akan sama nanti kalau you perasan. Bila you solve simultaneous, bermaksud they are sharing the intersection point. They are sharing the intersection point. Maksud saya is, cuba you masukkan L1 and L2. Okay, in X and Y. You akan dapat the same. But Z not. Ini yang this process is trying to tell us. This process. Ini simultaneous we get these two values, means these two values, they are sharing the intersection point. Kalau kita substitutekan T ni into this, you dapat apa you? Into line 1. Dia dapat apa? Kalau T equal to -1, S equal to -1. Dia dapat apa? T equal to -1, apa you dapat? -1, so we get 3, right? It's 3. Okay. How about this one? Kalau S, we have L2 relate with S is equal to -1, what do you get?
3.
3S, 3 juga kan? Okay. And Y pula, what do you get? Kalau S -1. 2, yeah? Okay, 2.
Yes.
And then for this one, S is equal to -1. So 2 juga lah, 4 minus 2, right? Okay. So 2. Okay. But here you notice ni, Z equal to for T equals to -1. Plus ke minus. So this one, -1, so become 9, right? 9. It become 9. Kalau this one, S equal to -1, it become 2, right? 5 minus 2. Right, okay. So you see. So this is actually the process that we are trying to say that they are not intersect, because there's only one single variable, yang lain pun memang tidak intersect lah kan. It must be the same for these 3 points. Okay. So ini sama tadi, dapat solution. So because 1 and 2 dapat akan sama lah, into the imagine kan. But when we substitute into Z, they are the same, they are different. So in other words, kan Z get different values lah for L1 and L2. But XY dia sama untuk L1 and L2. So kita kata lah kan, since ni kita cakap, since both sides are not equal, and both sides are not equal, then L1 and L2 and L1 and L2 do not lah kan. Okay, do not, saya silap ni. Only not, okay. If both sides are equal, kalau dua-dua ni equal, then L1 and L2 intersect. But now in this case, kan, both sides are not equal. So L1 and L2 do not intersect. So kita akan cakap, since L1 and L2 neither parallel nor intersect, then L1 and L2 are skew. Okay tak? Maksudnya, in order to check either L1 and L2 ni skew ke tidak, you have to check these two dulu. Check for parallel, check for intersect. Okay. So the idea is the same as this. You boleh try buat. Look at this. And this one has been discussed in this example. So this one is considered as your homework lah. Boleh you all? That's your homework. Bila Jumaat kita tak nak buat discussion Jumaat rasa nak buat kelas tak? Nak raya. Saya ingat Jumaat saya nak buat juga lah macam yang hari tu. Kita bincang exercise 12.2, 12.5. So 12.5 is actually combination between equation of line, equation of plane. We go to equation of line first. For example, the questions maybe saya boleh forward. Forward. Forward to S then forward to jadi group tu macam sikit ni. This one is exponent. Okay, if you look at in your group here, okay, there are a few questions yang saya dah highlightkan ya. A few questions saya dah highlightkan for jom kita try bukan. So far equation of line, okay tak rasanya? Kita habis dah untuk line ni, untuk line dah habis. Ini video yang last week ni saya sharekan kat you all. Masuk ni.